Hi everybody. Today I'm going to show you a few problems in a row about areas of shaded zones. We're going to start with this pretty typical question. A regular hexagon inscribed in circle Z. It tells me that the circumference of the circle is 12 pi, and I'm supposed to find the area of the polygon, the area of the circle, and the shaded area, that area that's shaded there. A couple things you want to think about right away. I'd want to know the radius of the circle, wouldn't you? If the circumference is 12 pi and the circumference is 2 pi r is equal to 12 pi, we can see that the radius would have been 6. And when we're working with a hexagon, this is specifically for a hexagon, a thing that works really nicely is to think about these 6 equilateral triangles that make up the hexagon. There's one of them. And I'm going to build an altitude in that equilateral triangle, which is in fact the apothem of the figure. So if the radius was 6, yeah, that would have been 6. That is an equilateral triangle. This full angle would have been 60, one of 6 equal parts of the circle, giving me 60 degrees arcs, and the central angle same as the arc it cuts. But this angle would have been 30. So that part would have been 3. And the apothem, if we cared about it, and we should, is the short side times the square root of 3. 3 square roots of 3. And then I'm just going to go to that formula for the area of a regular polygon. That would be 1/2 times the perimeter times the apothem. So in this case, that would be 1/2 times. And the perimeter was, since the radius is 6, and these are equilateral triangles, each side is 6. You've got 6 of them, that'd be 36, huh? Times the apothem, 3 square roots of 3. Work through that, and 1/2 of 36 is 18, and 18 times 3 is 54. So we'd have 54 square roots of 3. I think that's the area of the polygon. I gotta be honest with you though. If I were doing this by myself and no one was watching, I'd probably just find the area of one of those equilateral triangles and multiply by 6. I remember that formula, side squared, square root of 3 over 4. That would have been 6 squared, square root of 3 over 4. Side squared, square root of 3 over 4. That's a formula for the area of an equilateral triangle. That would have given me 36 square root of 3 over 4. That'd be 9 square roots of 3, huh? And if each one of those equilateral triangles is 9 square roots of 3, and we have 6 of them, that'd make the total area 54 square roots of 3. So that's a good check. I think we got it right. Hey, what about the area of the circle? That's the next thing I was asking about here. You say, well, that's pi r squared. And I say, yeah, it is. And since the radius was 6, that would have been pi times 6 squared, therefore 36 pi. So what about that shaded area? The area inside the circle, within the 36 pi, but outside of the hexagon, outside of that 54 square roots of 3. Yeah, that's going to be the difference, isn't it? 36 pi minus 54 square roots of 3. I know there are other ways you could have done that. You could have found the area of a sector and subtracted the triangle to get that shaded area and then multiply by 6, but this is a good way to go too. There's different ways we could work these out, and you're invited to try other methods. Here we got a circle inscribed in a square. It tells me that the perimeter of the square is 28 millimeters. And if that's true, then I guess that each of the side would have been 7. I'm not liking that so much, because that gives me a radius, if the distance across there is 7, of 7 over 2, or 3.5, but I'm going to work with a fraction. So what would be the area of the square? Well, if it's 7 by 7, it's a 49 square units, huh? 49 units squared. And the area of the circle, well, I got to go with pi times the radius, 7 over 2, squared. And that would be 49 pi over 4. Just keep the pi handy, square the numerator and the denominator, and that would be the area of that circle, 49 pi fourths. And the shaded area, I hope it's obvious to you, it's got to be inside the square, so it's got to be inside that 49 units, but it's outside the circle, therefore take away that 49 pi fourths. Here we'd have 49 minus 49 pi fourths. That's sort of a pretty thing. Could you think that would that be the same as 49 times 1 minus pi fourths? Not important, but aren't these the same thing? If you multiplied that 49 through the parentheses, you'd have that same answer. I just think it's interesting when a couple of numbers show up like that. We could factor it. But either one of these answers is fine. I think this is probably the one we would expect. But if you're taking the SAT and they showed that answer, you might want to think about it, huh? I got another one I want to show you, a few more. Here's one that you'll see again, I think. Here we have a rectangle with 2 semicircles, and it tells me that AB is 20 and AD, this side, like this side, would be 16. And I want to find the area of the shaded zone. Got a couple things to work on. I got this semicircle and another semicircle and a triangle. I think I'll get them piecewise. There's no one formula that can do all of those. How about the area of that triangle? It's just part of this rectangle. It's got a right angle here. I got a base of 20 and a height of 16, so 1/2 times 20 times 16. That'd be 160, wouldn't it? Unit squared. Half of 20 is 10, and 10 times 16, yeah, that fits, doesn't it? But then, if this side is 16, wouldn't AD have been 16? Therefore, the radius would have been 8. The radius of that semicircle. The area of that circle would be 64 pi. But the semicircle, I didn't spell that well, would have been 32 pi. So we got 32 pi for that part right there. And 160 for that triangle right there. How about that semicircle up here? Since this distance is 20, the diameter is 20, then the radius would have been 10. The full circle would be 100 pi, pi times 10 squared, but we got half of that. So that must be 50 pi. So what is this shaded area anyway? Well, I have that 160 that came from the triangle. Plus, got these two semicircles to add up. One of them give me 50 pi for the larger and 32 pi for the smaller. That ought to give me 82 pi, huh? And you can't add them up any better than that? I said, no siree, you cannot. That's 82 pi and that's 161s, and those are different. Can't sum those any better than that. And here comes a pretty fun question right here. I got a couple ways to work it, and I want to show you about them. Here we say this is a square, and AB is 12. So we got a 12 by 12 square. And arcs, these arcs DB, this arc DB has its center at A, and this other arc DB has its center at C. They're arcs of a circle. I'm just going to wing it and show you what I meant by that. Yeah, there's a circle that does that, and there's a circle that does this, but I'm thinking about how can I get the area of that shaded zone right there? And a thing that occurs to me, that's something that you could have seen already, is what if I found the area of that segment? I think that segment, along with that segment, would be the same as this, if this were also a 12 by 12 square. So I'm just going to focus on that one segment right now. And that ought to be the area of the sector, minus the area of the triangle, would give me the area of that segment. So I'm thinking, well, okay, what about the area of that full circle? And that'd be 144 pi. But I'm only going to have a fourth of that circle right there because I got 93/60ths of it. So I got 144 pi divided by 4. And that'd be 36 pi. That's the area of the sector. But what if I subtracted that triangle away? And that's a triangle with a base of 12 and a height of 12. The area of that triangle ought to be 1/2 times 12 times 12. That'd be 72, huh? So let me think this through. If I took the sector, 36 pi, and I subtracted the triangle, 72, that would give me the segment. So let me write that down. 36 pi minus 72, there's the segment. But wouldn't this full thing, this zone, have two of those? So I ought to multiply that by 2. That'd be 72 pi minus 144. And I think that worked okay. I think that's a reasonable way to have worked it. But let me show you this other thing that occurs to me. Here's a funny thing. What if I took this quarter of a circle right here? And I think I could find the area of this quarter of a circle. Let me show it to you first. You could get the area of that quarter of a circle, couldn't you? Pretty easily. This is a 12 by 12 thing. And let me show another quarter of a circle going this way. This is just an alternative way to solve this question. But it kind of makes sense, and it's kind of beautiful. I got another quarter of a circle there. And I just ask you, if I added this quarter of a circle to that quarter of a circle, would it be the same as the square? And you got to say, no, it would not be the same because you would have counted this area twice. The area that I'm curious about. That makes me think if I took the area of the two quarter circles and I subtracted the area of the square, that would give me this zone. Let me write that down. The area of the two quarter circles minus the area of the square. Because if I add the two quarter circles together, how is it different from the area of the square? And because this zone was counted twice, it's different by that amount. That would equal the area that I care about, area of that shade. Let's see how that goes. Okay, the area of the whole circle would have been pi times 12 squared. That'd be 144 pi. But I only got a quarter of the circle there. So that'd be 36 pi, wouldn't it? But there's 36 pi for this one and 36 pi for that quarter of a circle. So that makes 72 pi. But subtract the area of that square away from it too. That'd be minus 144, huh? And it's interesting to me that we get exactly the same answer with completely different strategies. So I'm here to tell you that that little zone is 72 pi minus 144. I got another one I think is kind of beautiful too. Flower question. How about this? The perimeter of this square is 48. That's a square right there. That makes the size have to be 12, huh? And I want to figure out the area of that flower. Honestly, this thing is like one of the petals of that flower. But I'm gonna work this through the best I could. I think a thing that most people might try is break it into 4 equal parts and study that one petal. In fact, you could do that by treating that as a segment and just getting the area of that little zone right there. And if I double that, I have one petal of the flower. And if I multiplied that by 4, I'd have the whole area of the whole darn thing. So I'm going to work on that for a second. Let me sketch it again. Don't be shy about making sketches. I got this 12 by 12 square. And I want the area of this segment of that circle. That ought to be the area of the sector minus the area of the triangle. We give you the area of that segment. The sector, because it's 193/60ths, yeah, 1/4 of the area of that circle. 1/4 of 36 pi, there's 1/4 of 144 pi, there's 36 pi. Minus the area of the triangle, and that's 1/2 times 12 times 12, isn't it? 1/2 times the base and the height. And that'd give me 72. So 36 pi minus 72 for that zone right there. But this zone would have been the same. So that would have been times 2. That would be 72 pi minus 144. And if you wanted all 4 of those petals, you have to multiply that by 4. Let me write that down and see how that goes. And that would be 4 times 72, I think it's 288 pi minus, and 4 times 144 is 576, I'm pretty sure. 576. Alexa, what's 4 times 144?
4 times 144 is 576.
Okay, so that's what I say the area is. And I think that's a pretty good way to work it. But check this out. I sketched it again, kind of a crude sketch. Let me show you this thing. Same picture. Still got a 12 by 12 square. What if I took the area of this? I think it would be easy enough to find the area of this semicircle right here. This semicircle I'm shading. This is a kind of a wilder way to work it. Just take the ride and see what you think. I think it works pretty great. Could you find the area of that semicircle I'm shading right there? That'd be pretty easy, huh? It's got a radius of 6. The area of the whole circle would have been 36 pi. But that's a half of the circle, so the area of the semicircle would have been 18 pi. Now hold that thought. So if you took the area of that semicircle, it would be 18 pi. But what about this semi? Let me shade this the other way. This way. And be patient with me, I'm doing the best I could. If we could take the area of this semicircle as well, I'm going to shade all 4 of those semicircles as I move around here. And this one too. And my thoughts are, would that be, when I shade all 4 of these semicircles, would that be the same as the area of the square? And we'll take a look at it right away. I'm just shading those 4 semicircles, going to shade inside of it this way this time. Just inside of that semicircle. Whoa, just about got it. Now, so, look at this interesting figure. If I added up the semicircle here, plus the semicircle there, and this semicircle, and the last one, would that be the same as the area of the square? You got to say, no, mister, it would not, because these 4 zones got counted twice. So that's how those things must be different, since that area was counted twice. So it makes sense to me that it would have to be the area of the 4 semicircles minus the area of the square. How are those things different? Well, they're different by the area of that flower. Okay, so what's the area of those 4 semicircles? Well, each one was 18 pi. Is that true? If the radius was 6, is it a 12 by 12 square? Yeah. Oh, see what I did up here? I made the radius be 12, and the radius needed to be 6. So I got to work this thing again, homies. Let's do that again. If that would have been 6, and that would have been 6, that's going to make a little difference, wouldn't it? That would be 1/4 of 36 pi, and that would have been 9 pi. So, I got to be careful here. What's the area of that zone right there? It would have been the sector 9 pi minus the triangle, and the triangle was 18. So that little sector, that segment, excuse me, is 9 pi minus 18. 2 of those to give me this whole zone right there would have been 18 pi minus 36. I got to reevaluate this. I'm sorry for that error I made. I just missed the radius, which is a thing that happens all the time. So if this zone was 18 pi minus 36 and it's one of 4 equal parts, let me multiply 18 pi minus 36 times 4. And that would give me 72 minus 72 pi, excuse me, minus 144. Okay, so I screwed it up the first time, but I'm checking it, so I'm glad that I am. What's the area of those 4 semicircles? Well, they're all 18 pi. And 4 times 18 pi is going to give me 72 pi, huh? That's what I saw that I was missing last time. And then minus the area of the square, and the square is 12 by 12, that's 144, huh? So there it is, right there. I say that must be the area of that flower, which does agree with what I got when I used the proper radius. So I'm sorry I made that error, and you got a few things to think about yourself. Be careful with the radius. People can make a mistake there. So you're going to work on a thing called areas of shaded zones. Do a great job, and we'll be in touch.